This is 3-2, relations and functions. There's a lot of vocabulary here, but I'll go through it throughout the examples anyway. The main things that I want you to know is an ordered pair is x comma y. Eventually you'll have an x, y, z on a 3D coordinate grid. So that's why it goes in alphabetical order x, y. The other thing I want you to know is that a relation is a set of ordered pairs. So a relation for a set of ordered pairs might look something like this: 0, 1, and then another ordered pair like 2, 3, and another ordered pair maybe -2, 4. It's just a list of ordered pairs basically. And the word function is a special type of relation that pairs each domain value with exactly one range value. Again, I'll go into more details on these vocabulary words as we do the examples. Okay, here's an example 1. So one of the vocabulary words was a relation. A relation is a set of ordered pairs. So here is my relation, my set of ordered pairs. And I'm asking you to create a table, like an XY table, a graph, and a map of these ordered pairs. And so I'll show you what those look like. Okay, for the table, I'm going to list all my x values first, just because I want you to see that the x values are all the domain. So here's my x values, and it's 2, -2, 5, and -1. And now I'm going to list all of my range, the y values. So 5, 3, -2, -2. And so I'll write those out, 5 and the y, 3, -2, -2. And now to graph these, we have to remember that the x-axis is like a number line and the y-axis is sort of like a thermometer. It goes up and down. As you go up the y-axis, it's positive. As you go down the y-axis, those are our negative values. And for the x-axis, when we go to the right, those are positive values, and to the left are negative values. And so we'll count all of these as 1, so 1, 2, 3, etc. 1 unit per block there. So if I'm graphing 2, 5, remember that's x, y. So I'm going to go to 2 on the x, and I'm going to go to 5 on the y. 1, 2, 3, 4, 5. And I'm going to mark that as 2, 5. Actually writing the coordinate right next to it is super helpful. So we're going to practice doing that so it becomes a habit. Our next order pair is -2 on the x, +3 on the y. And then 5 on the x, -2 on the y. Label that 5, -2. And then -1 on the x, -2 on the y. The map should be new to you. When we make our map, the x values go in the first oval, and the y values is kind of a rectangle. Usually it's an oval. And the y values would go in the second one, and we place our numbers in numerical order. That's what's different about a map. Okay, so in numerical order. So my x values, the lowest was -2, then we have -1, 2, and 5, and I do the same thing for my y values. We had -2. I'm not going to write the repeated -2. We don't write the repeated numbers. And then 3 and 5. And then we map. So -2, the ordered pair -2 went with the y value of 3. The ordered pair -1 went with the x went with -2 for y. The x value of 2 went with +5, and the x value of 5 went with -2. So the other important word, I've already said this once before, but just if you didn't catch up onto that, the domain are our x values. Domain are x. And so I'm just listing out all my x values in numerical order, so it's like the same as the map. -2, -1, 2, 5. And then my range, that would be the y values. The y values, and the y values in numerical order are -2, 3, 5. The domain and range above would be discrete. They're very specific, and sometimes we have to write a domain or a range for a continuous graph, and that looks a little bit different. That's using a compound inequality. So let's take a look at that. So for example 2, it says to give the domain and range of the relation. So for this, remember the domain are the x values, but notice that the x values go all the way from 1 to 3 inclusive. It includes 1 and 3. So it's going all the way from 1 to 3. So we can't just say 1, 2, and 3, because what about all those numbers in between? So we write that as a compound inequality. Smallest number, 1, less than or equal to, because of the closed circle, x less than or equal to 3. Remember, this is an intersection. This picture is the same as an intersection. So it's an and inequality, and so that's why I'm writing it the way I did for the domain. And the range is the same idea. For the range, we're going from 2 on the y-axis all the way up till 4. So I'll show you what I mean by that. It starts at 2 on the y-axis and it goes all the way to 4. We could also write these as ordered pairs, and it might help you to see that that's the highest point we're getting to. Okay, so from 2 to 4, what will we do again? Small number 2, less than or equal to x, which is less than or equal to 4. For example 3, since the domain and range are distinct points, this is discrete again. So for my domain, I'm going to list out the values from smallest to largest, 68, 75, 125. And for my range, my values would be 2 and 3. I'm not going to write the repeated 2. So to tell whether the relation is a function or not, you need to see if each domain value is paired with exactly one range value. So this relation is a function. This always confused me, so what I look for is that there's no double in the domain. So notice in the domain, none of the numbers repeated. So it's a function if there is no double in the domain. So to me, this makes more sense. If that's easier for you to understand, use this one. Maps are hard to read sometimes, so I'm going to list out my ordered pairs. I'm actually going to make an XY table instead so I can see this a little bit better. So I have for 7 as an X, the Y paired with that is -1, but there's also a 7 paired with 0. So there's a 7, -1, and a 7, 0. Then there's a 9, -7, a 12, -1, and a 15, 0. Now that I see this, I can very easily see that this is not a function because there was a double in the domain. So this right here makes it not a function. You can't have a repeated domain. So basically, each domain value does not have exactly one range value. Now if I list my domain for this graph, my x values go from -4 all the way to 4. So small number less than or equal to x, less than or equal to 4. And my range values, same thing, go from -4 up to 4. So -4 is less than or equal to x is less than or equal to 4. Because this is happening, there are several domain values that have more than one range value. So this is not a function. But there's another way to tell that. So on the compound inequalities, it's hard to see that, but there's another way to see that this is not a function. There's something called the vertical line test. So if you do a vertical line test, what happens is you take a vertical line, and you could do one line anywhere on the image that you see. So this blue line I just made, and it should only hit, if it's a function, it should only hit that image one time. This is hitting in 2 spots. That's like a double domain basically. So this is not a function. For the vertical line test, the vertical line can only hit one spot on the image. The vertical line can only hit one spot. One point. There are too many points that are hitting, so there'd be a double domain on those 2 spots. It's no good.